introduce Abby and myself.
Yeah, so as we've said, Abby's not going to be around, unfortunately, to grace us with her presence. But yeah, you've got Deadpool to keep you going. So, Charlie, you can
Deadpool's
take it
actually
away
me.
yourself, can't you?
Yes, thank you. So Abby had an emergency come up. She kind of sent out a message over the weekend, and she's got something else. And so we had coordinated, and we've worked together plenty of times, and she's excellent. And so we had a bunch of stuff. I've taken and used that presentation, but in a few places, she was going to do a certain part of a demo, and the demo was a slightly different demo set, data set. It's essentially the same storyline. We're doing the exact same scenario, but the original one was looking for fraud in a banking situation, and I switched over to my data set looking for fraud in an automobile insurance claim. So very, very similar. Stay tuned. Abby and I will probably get back together on stage and do that at some time, in the future. So I am going to hide the meeting controls and see if we can go to the next slide. So there's our background. Dr. Abby Hayes, Chief Data Science Officer at Vertees. She previously was at the UK NHS. You can see a lot of the public stories there. She's got speaking awards. She's a technical evangelist. She's a PhD in computational modeling. She's very, very skilled, very, very good. I've always learned things from her. It's too bad that she is not here to join us. I am not actually Deadpool. I just like the movie, and we had to pick somebody. I'm the Senior Director of Product Management for Machine Learning here at Oracle. I've been here for quite a while, and actually one of the co-founders, along with Sham Nath, who I think is also somewhere out there on the Zoom sphere out there. And so we're happy to have you here, and I will go into my our presentation here. So someone tell me you can see the slides?
Yes, we can see it. You're looking good, Charlie.
All right, super. Thank you, guys. So I will, over the next 45 minutes or so, give you a journey in fraud. And what I liked about this, I saw Abby do something that I've always talked about, but never actually kind of put it together. So I started going down the journey to do it. She had already shown it, and we said, hey, let's team up and do something. And the idea is you're trying to solve a problem, but fraud's a hard thing to solve, right? I mean, you don't have necessarily a bunch of examples. Now, I do know a guy at a bank that was using my product, and he was using it for check fraud. And I said, oh, you're using a special anomaly detection algorithm, right? Because you're trying to find very rare things, so you need to use specialized techniques for that, right? He said, no, we have way too many examples of check fraud, so we do typical classification kind of techniques. So, it depends, but in a lot of times, when you approach a fraud problem, at least in the beginning, you have a lot of expertise, but you want to automate that as best you can, and you want to help out with that. And there are certain techniques that can be used there. I'll cover those. And then you can augment that with domain knowledge from users, and then you can build even better models. So that's what this fraud journey is all about. And I'll do my best to cover for what both Abby and I would have been doing together. Notice the little dots on the left on some of these slides. Those were going to be the ones like, okay, Charlie talks about this one, or Abby talks about that one, which I thought was pretty cool. And so there's our Twitter feeds. You can follow us there, and please do if you have not other things to do. And so this was something I got from her that I put in the little bit more detailed notes here so I could do a better job on this slide. If you Google it, the first fraud case was in 300 BC, the first documented fraud case. It was a Greek sea merchant named Hegestratos, if I'm pronouncing that correctly, and he wanted to insure his ship and the cargo, which was corn, so he took out an insurance policy. But what is possibly the earliest recorded attempt of first-party fraud, Hegestratos planned to sink his empty ship, sell the corn, and keep the loan. So he was actually caught in the act of sinking his ship by his own crew. He was chased off the ship and drowned trying to escape from them. So fraud, never pays, but it's interesting that it goes back that far. And so fraud, my involvement with fraud and helping other customers that do fraud is it's always, it's a hard thing to find. Most of the people I find that are in the fraud business, I think I saw Carl Rexer somewhere out on the wire out there. I first did this, I don't know, years back with Carl, where he invited me to go to a fraud society event of some sort. And so I Googled a little bit, got a little bit smarter. Carl had already been doing some more work in the area, but all the people that were there, this is like 10, 15 years ago, were all, basically people with detective cop kind of brains. They were using their hunches, their intuition to sleuth their way through a bunch of data and a bunch of example of fraud or possibly fraudulent, you don't know, claims. And it's kind of hard work using your brain. And so the question is, can we utilize technology to help us become crime fighting superheroes, sticking with today's theme? And so there are lots in the scenario that we're going to do right now. I've switched it over just a little bit. You're going to see it toggle back and forth a couple of times here. I hope not too much and you don't sort of get dizzy from that. But we've switched over to this Gecko automobile insurance company, and they have lots and lots of automobile claims and transactions within the auto insurance. So a lot of people are crashing up their cars. They're submitting for fender benders and big accidents and single car accidents and witnesses present and no witness present and so on. And so the Gecko Insurance Company wants to try, and this is a fictitious one, obviously. The Gecko Insurance Company wants to try and see if they can use some technology to augment what the humans do, because the humans are good at spotting patterns. They can spot things with the human eye, but there's a lot of claims here. So what we want to do is try to use Oracle machine learning. And I'm going to go into just a real quick overview of what Oracle machine learning is. Then we'll get right back to our story, but it's kind of important. Now, Jasmine just showed you all this a little bit earlier, so I don't mean to be repetitive, but Oracle machine learning, it's part of the database, and it extends the database to enable users to build more of AI. And I cringe when I say that because I lived through the second AI winter back in the 80s, I guess. It's always oversold, but it really kind of works, right? You're using data, you're using algorithms, you're finding patterns. And so, you call that whatever you want, insights, predictions, AI, whatever, but we're harvesting greater and greater information from our data. So these are 30-something algorithms that are inside the database, and they are in database implementations. So there are, many patents out on this, many intellectual property, secret sauce things about what we've done here, but we also expose that via different ways. Now, Jasmine showed the OML for SQL, the SQL API in her presentation. I will show that. I will show also the notebooks because everything's kind of moving to the cloud. So we're focusing on the cloud more and more these days. But you can also use Oracle Data Miner, the drag and drop GUI. You can use our integration with R, so you can speak the R language and drive these same algorithms. We call that OML for R. And you can use the new Python that's coming out later on this calendar year, where you can speak the Python language and drive the in-database functions. Now, you can also use R and Python to do whatever you want in R on premise or on Python. When it first emerges, it'll first come on the autonomous database, and we will have preloaded things like scikit-learn, matplotlib, and a few things like that. So it'll be a subset of packages you can use there. So you can use any of those packages or any of the base Python, base R, but you can also use them, I think more importantly, to speak your native tongue to drive these 30-something algorithms in the database. And as Jasmine said, there are many advantages, we think, to moving the algorithms to where the data resides, so that if you build a model, it's pretty straightforward to apply the model, right? It's run a script, apply the script, whether it's a notebook, a GUI, a button, whatever, but it's all just basically a function inside of the data management platform. So Oracle tries to make machine learning simple. And I think it's the most important thing. There is no extra cost. So hopefully many of you on this call have the Oracle database as of December 5th, 2019. And you can Google this. Willie Hardy put on a blog out on this. So you can see it. But spatial and graph was another option, and Oracle machine learning were both made, no license required. They're made differentiating features of the Oracle database rather than a separate a la carte thing that people would have to buy. And that really has changed everything. It's really moved the needle because now you have this database managing all your data, and you can go ahead and start to analyze the data. And in fact, all of these functions actually come even in the free Oracle Autonomous database, which I will show. I guess I have a free instance, but I'll probably show my non-free instance because that's where I keep most of my work and data. But you can tune in even during this presentation, just Google Oracle Autonomous Database, take out a free account, and all these algorithms that I'm going to show on the next page are yours to use. So it's really pretty amazing. It's like going to Google Drive, and just putting all your data up there and then using machine learning on that data. So in Oracle machine learning, inside the database, we have over 30 algorithms, and it keeps on growing. With each major new release, we add 1, 2, or 3 more algorithms typically. And under classification, you see the naive Bayes, logistic regression, decision tree, and so on. Jasmine used in regression, she used the linear model, she used the GLM, support vector machine, stepwise. These are different techniques we have inside Oracle machine learning. But my point on this is we pretty much have a machine learning power tool implemented natively inside the database for most problems that you might encounter. And that's the major thing, right? You don't have to move the data, so we collapse the time to build and deploy a model from really, and then to deploy the model is the part that really slows everything down. But we collapse that thing from weeks to months down to just build a model, score a model. It's a script, and you could build the model in one database, let's say on-prem in a development system, and then move it up to the cloud and deploy it. Is just moving the model and the script to the other platform. But I think the real coolest thing of all this is that everything that you're doing also is alongside peer functionality to all the rest of the Oracle technology. So if you want to build a partition model on who's going to vote for this person or that person, partition it by state and gender, you've got 100 different models. If you want to use the transactional data, well, you just use aggregations inside the database. We do that. Unstructured data, I always joke, if marital status were not single, married, divorce type of categorical varchar fields, they were instead like paragraphs of text, a bunch of tweets, a prenuptial agreement. We could use Oracle text to tokenize all that data and bring in a vector of terms. And all of that is fair game for the Oracle machine learning algorithms to do their magic and find the patterns and make predictions. So the goal from Oracle more and more these days is not only to manage all your data, but also to analyze your data. And I think we have on Thursday, on the Analytics Plus Day, we have some great talks, I think, by Certegy, by Hartford Healthcare, that are using not only the machine learning but the Oracle Analytics Cloud to combine, the reporting and the interactive graphics, but with the machine learning, the predictions, to make an even better, solution. So I really encourage you to come back and see some of those talks. So today we're going to focus mostly on using the notebooks. We could do it on-prem, we could use R. But I'm going to use mostly the notebooks, the SQL language paragraphs within the notebooks, because the Python is coming out in a matter of weeks. That's been a little bit overdue. It's coming any time now. I'm just going to say before the end of the year, just to be sort of safe on that. I don't want to tell you it's tomorrow and then it's Thursday or something like that. So before the end of the year. Jasmine also talked about the engineered features, which I think is really the coolest, or the most important, not the coolest, the most important part of any predictive modeling that you're going to do, because it's garbage in, garbage out. If you don't have the right predictive variables as inputs, you're not going to be able to get a good model. And that's where your domain expertise, I think, really comes into play. So I'm going to go through these Oracle machine learning notebooks. They're included in the autonomous database. They're collaborative user interfaces. I work with a lot of other different people, putting together demos, solving problems and doing things. And it's really kind of interesting because you're all in the same notebook, and I say, hey, update that paragraph or change this code. Did you do that yet? And it all just updates. And it's like a collaborative user interface notebook. It does exactly as it says, and it really is nice for data science teams across the planet to collaborate, simultaneously within the same analytical notebook. It really is kind of cool. So we're back to our use case, and we're going to take this as problem 1 and problem 2. So we're back to this Gecko Insurance. We have an automobile insurance company. They have lots and lots of claims that are being submitted for, like, hey, I had this fender bender for $500 on my old beat up Ford, or I have a fender bender on my old beat up Ford that's worth $25,000, or it happened last night, there were no witnesses, whatever. We want to help the experts who are just inundated with way too many claims. We want to help them out by trying to triage things. So when we use typical human-driven rules, we're looking at the data to try and find patterns. We may use SQL to select those patterns, like show me all the insurance claims that had no witnesses present, and the police report file. The police report was filed, but after, I don't know, after 15 days. We think that after 15 days, maybe that really indicates something. So you're going to do selects. You're going to use sorts. You're going to use domain knowledge to set up the data in such a way that then the experts can kind of go through it. And maybe at that point, what they do is they go out and investigate it. They get in their car, they make some phone calls, they go on the internet, they search out to see whether they should really pay Charlie Berger, the $15,000 repair on my old beat up Toyota Corolla that I used to have, I don't know, a long time ago, I bought for $2,500 or something. So should they really, repair that? There are other techniques that you could use and I'll go through that, are the machine learning techniques. Now there's unsupervised machine learning where we're really going to look for anomalies in the data, and that's what we're going to do first, is the unsupervised. We're also going to later on come back as a second wave doing supervised models after the experts have sort of jumped in and added their additional value. So I think that's a really clever part of the story here, and hopefully you're going to like that. So first of all, what is machine learning? Kind of a more rapid build than I wanted there. Sort of a rapid build there to show I have a bunch of data. I just have two variables, income and customer months, and I'm trying to find or fit a line through this data. And if I try to fit a straight line or even a more quadratic or cubic line, it's not going to separate those two different classes of, let's say, lease churners or fraudulent, yes, no, but a binary classification problem here. It's not going to do such a good fit, but something like a decision tree is going to iterate through that. It literally checks every single one of these cut points along here until it finds sort of a curve in the data and realizes there's a change. Similarly, it goes up the other variable. And we go through this, if you had 500 variables, it would iterate through all those 500 variables until it found sort of an information gain, curve in the data. And the nice thing about the machine learning, and then it's going to iterate, split, iterate, iterate, iterate. That's what the decision tree does. The nice thing about the decision trees are that it also shows the English-like explanations of what's going on here. So here we say 1, 2, 3, 4, 5, 6, 7, 8 out of 8 people that if their customer months is greater than 14, because we discovered that sort of curve in the data where things really sort of changed, and their income is less than this, we discovered just basically by counting things inside the database that 100% of these people in the past all did in fact churn their lease. They left to go to, they turned it in, didn't get a new lease. And the sport of that is 8 out of 39. So it's 39 total people here. So that's about 25%, just under 25. So if I find these people, I'm very, very confident in what's going to happen if I use the past as a predictor of the future. And similarly, I have another pattern over here. But if I go to a fraud kind of problem where I have maybe just two guys or none, then how do I fit a line through that? It's very, very hard. So we're going to use different kind of techniques, and what we're going to use are when we lack sufficient past examples, we're going to use this anomaly detection kind of concept. So the best way I think of showing that is using this good old Where's Waldo sort of book. Now I'm told that Where's Waldo is published in many different languages, and my sampling of a few different people is that they've seen and they know who Where's Waldo is. So hopefully this is not too much of a strange idea. But there's this guy Waldo, and he's got this crazy hat and striped shirt and a cane and blue pants. And the challenge it's a children's book typically. The challenge is, can you find Waldo in a crowd, maybe at the beach, at a market, at a fair, at some large gathering, maybe at Oracle Open World? Can you find Waldo? And I'm just going to give you, a short amount of time. This is the challenge that the insurance adjusters have to do every single day. They get a lot of insurance claims. They have to find, the ones that might be fraudulent. So get ready, go. Can you find Waldo? Well, time's up. And there is Waldo right there. But notice how your brain works. You see this woman over here with a little striped sweater. You see somebody else over here with some striped stuff down here, a little bit stripes, but they're vertical. They're going the wrong way. You're looking at a guy over here. Your brain, here's checkered up here. Your brain's kind of sifting through all this stuff, looking for what stands out. And you're kind of trying to pattern match until, whoa, there he is, blue pants, striped shirt. And that's what we're going to try and have the algorithms do. So in Oracle Machine Learning, we have all these example notebooks. It comes with the product. And what I've done is I've taken this one here, and these are all very simple. I've written, most of these myself, and maybe had some help on some of them, but they're very straightforward. They're very simple, but they are very useful because you can just repurpose them. And a lot of my customers that have had success using Oracle Machine Learning do exactly that. You come into your instance of the autonomous database, you open up an example notebook, you export it because you can't run it there. It's an example, so it's read only. You export it, you import it into your own space. So I'm going to do that, but before I go in there and show the live demo, I want to put a build in here, or a jump to the next slide that's throwing me. In the under the hood, what this is doing is this. Okay, in this case, I'm doing the very manual, like set up a claim settings table, and then build the model, and then use the model. And I'm going to cut over here to show you this under the hood first, which is this. Okay, I can do another version of this claims model too, where I can embed this in here. I don't have this particular one going that way. I have other ones that do. But if I run this thing, and this is just running on my laptop, I also have it up over here on other connections up on the cloud, but I thought I'd just show this, locally real quickly. If I build a model, then on about 15,000 records, I've just built a model. And if I want to now run this model, I can run it. And under the hood, I'm showing you kind of like way deep under Oracle machine learning inside the database. This is what's going on. Okay, so it's very straightforward. If I want to just run this and schedule this and run this, we had a use case, I'm going to say, in a major city in New York that was doing this for fraud detection for claims against the city. And they would just run these scripts. I went to go see them when I was in town and said, well, where's the user? And they said, what user? And I go, yeah, the guy that's, using the machine learning. Where is it? Where's that person? They go, I don't know. I just, go to that terminal. There's a report that kicks out over there. And they just set it up as a scheduling kind of thing. So that's what you can do. I'm going to go now over to Oracle Machine Learning, and I've got to get this guy a little bit out of the way here. So I have right here an Oracle Machine Learning notebook. And first let me go back to here first. I am in Oracle Machine Learning. I thought it might do that, log me out. So I wanted to relog in here. So I'm in my own instance of Oracle Machine Learning. By the way, if you have not done this, if you Google Oracle Machine Learning getting started, there's a quick little YouTube video I put out there, but you can actually just go to your instance of the free autonomous database, click, 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 and it shows you how to get to this little sort of hallway. But I'm going to go in here to the notebooks, and I've done a few different notebooks. There are projects and workspaces in here. I'm going to skip over the sort of the tour of all the different notebooks and workspaces. I'm just going to go right to today's business, which is first doing these unsupervised learning notebooks. So the data that we have here is about automobile insurance claims, and the use case is trying to find the ones that stand out. Okay, it has a little bit of a description here of what's going on, a little bit of background about the industry, and we're going to use the one class subword vector machine algorithm. Why? Because the one class SVM, it trains on normal records. So you feed it normal records, and then it's still finishing this loading right there. You feed it normal records, and then it's going to say, well, that's my model for normal records. Apply it to new records, or even the same, population of records, and it's going to sort them in their order of being dissimilar to the training population. So here's the business problem. We want to sift through our recent automobile insurance claims, looking for anomalies that are suspicious and potentially fraudulent insurance claims. We're using an unsupervised learning OML one-class subword vector machine algorithm to build and apply models on this, what we're going to call unlabeled data. Okay, there are no examples. Now, part of this story is we're going to let the humans in to add their domain experience to say, yeah, that is fraud, that's not fraud. And they're going to come in and label the data, but we're going to try and help them out by sifting through the haystack and try to find the top 1 or 2%. So that's what we're going to do. They're going to assign them as fraud found, yes or no, for further supervised learning. We're going to do this fraud found using Oracle Application Express. Abby has created a little application in Apex, and we're going to show you how you do that. Then we're going to come back in. So first of all, I'm just going to let this guy, I'm going to run this guy right here, run all paragraphs, just so you can kind of see that. So I'm not clicking on each thing as it kind of goes by. And I ran this a little bit earlier. So as I sift through here, you're going to see, how long it ran, something 1 second to display the data, 0 seconds to do something down here. So we're just kind of letting the whole notebook run through its motions here. And we're going to do a few different graphs. After we've looked at the data, we said the week of the month, the day of the week, the make, the accident area, and who's the fault, what's the claim of the fault, what's the vehicle price, the policy number. So there's about, I think, about 25 variables in here, I think it was, and base policy, number of cars, a lot of interesting data, but also a lot of data to have to sift through. Okay, so the first thing we want to do is look at the data and see, well, we want to use our intuition, our hunches. Jasmine had correctly stated, your domain expertise is one of the most powerful things here. So I want to say, well, I think most of the accidents occur on the weekends, right? Well, it's actually, I would say, Friday and Mondays, with Saturday being next. But I also want to graph this male versus female, and it looks like most of the males are getting into trouble more than the females. I can look at this in a table of data. I can look at it in a graph, and that's what the notebooks do, is allow me to kind of toggle this around, that I can change the settings here to just say whatever I want to do in this. So it's a very not the best graphing tool. We're going to go over and see OAC and some other tools later on, but it's a reasonable graphing tool. Where do the exact accidents happen? They mostly happen in urban areas. Some happen out in the woods, out in the rural areas. We look at some other graphs here. We look at some other graphs, and some of these things I think I had set up at one point to do pie charts and such. I guess I have to run that guy again, but I'm going to skip down here. And I'm going to go down to, okay, now we're ready to do our knowledge section. If it were that easy to find my problems up here, doing it with a few graphs, then it really wouldn't be a problem worthy of machine learning. So I just ran this. It took, what, 3 seconds to build a model. Here is all it was really doing under the hood. It was just running this, DBMS, data mining, create model, claims model, classification. The data set we're using is this claim 0 that it lacks any kind of labels. It doesn't have this fraud found field in there. And the target column is what? It's null, because there's no known labeled fraud from the humans, from the experts here yet. So I built the model in about 3 seconds. Now I want to apply the model and sort them in their likelihood of being fraudulent. So here I am serving up, I'm just showing a few other variables here to display it, but it's the whole table. There's the most suspicious claim. And as I go through this one, I think the story was, it's a female, she's single, it's the highest one that stands out the most, 26 to 30 years old, no witnesses present, single car accident. And I think the thing that stands out the most to me is that she's driving around in a Honda Accord that's worth more than $70,000. So maybe that's the part that stands out. I'm not sure, but in a multi-dimensional, multi-peculiar way, it sort of stands out. So what we're doing here is sort of sifting through the data. We might want to then look at these suspicious claims and sort them by another field or two, do a little bit of simple graphing here. We can do more graphing over in the Analytics Cloud. We might want to say, well, I can only handle 5 a day. Show me the top 5 that I should go off and investigate. All right, so I get that. Show me all of them, and then we're just going to leave these results in the database. We're going to create a suspicious claims table, and we're going to leave that in the database, and we're going to come back here, and we're going to investigate that later on. Okay, so I'm going to pause right now. Are there any questions yet, Roger, from anyone?
No, sir. No, sir. Nothing yet.
All right.
Everybody's
so
believing you 100% here.
All right, so we just did the automobile unsupervised learning situation here. We did the business problem, and all the slides here will be available for you. We looked at the input attributes. We did some data understanding to see what was going on. If it was that easy, we wouldn't need machine learning, right? We built our one class support vector machine model to train on what we're saying are normal records. We're then displaying all the customers with their likelihood of being fraudulent in descending order. We're going to explore the suspicious claims, display the top 5, and make a model where we're having our list of our most suspicious guys, and do what? Leave it there in order to have the humans come in and capture their intelligence, because we have all these people that work at Gecko Insurance, and it's like that. There's a guy on TV that for Allstate or something says, we've seen a lot, we've seen this, we've seen that. Well, they've seen a lot. They have a lot of experience, more so than my algorithms have. So we're going to let their experience jump into the mix here. And what Abby has that she was going to show live, but I have to kind of fake it here with some PowerPoints, is an Apex application. So she has built a nice little application, and she goes through here and says how she's going to set this up. So she creates an application using Apex, and people way better than me in this area can do this, faster and better than I can here. But I've done this. It's not so hard to do. And we're going to create an application. We're going to call it the fraud CB application. We're going to create the application. And so there's little wizards that take you through this. And we're going to run the application once we get it up and going. But we're going to construct it. So we're going to create this page. It's going to be an interactive grid. And we give it some name. In this case, it's called the fraud CB labeling, because that's what we're going to do. We're going to let the insurance adjuster guys come in, the investigators, look at the records, and then with a drop-down menu say, yep, this is fraud, this is not fraud. So that's what it's all about, just a nice simple grid. And we're going to set this up, have some static values. Is it fraudulent or is it not? So remember what we're doing. We're doing through unsupervised learning. We're sifting through all the data. We're going to triage our records, leave the records in the database, have another user come in and use this application, and now they log on. Now, when we're going to do this live, we could have even maybe done this on a mobile device. So now you're you're driving around your car and you're saying, well, where should I go to next? And it has a little pop-up window. Well, the predicted most suspicious ones are the following, and there they are. I've got my Gecko Insurance app. I can run this, and in here are this field expert label. Fraud found, fraud not found. So as I go through this, each one of these things, this transaction, this is where we were switching back and forth between the bank and the automobile insurance claims. So this was a bank scenario, but kind of close your eyes, squint a little bit, and pretend this is the automobile insurance claim. So we're going to say, is it fraudulent? Yes, no. And I'm going to try and see if my other instance is still working over here. I'm going to go back over to here, and my screen is kind of, so this is another one that I have that I'm working on with another fellow, Do-Hoon Kim, and hide video controls. So this is a similar one where I can come into here and see my suspicious claims, and maybe have a drop-down menu. We don't have the drop-down menu in here yet, but I can also show, oh, it has expired. So if that's what I thought was going to happen. Oh, right here. Luckily, my password is less than 25 characters here. So here's a nice simple application here, and this is my suspicious claims report over here, which is going to allow me to go through here and see the probability, the prediction, the probability, but also I have something called prediction details, which are giving me the reasons why. So this says the address change, and I know this is XML format. There's ways to clean this up. And in fact, OAC is now in the latest release has picked this up, and they clean up that XML. But I see it's a sport car. It's the age of the vehicle is 3 years, and this gives me the reasons why, but it also gives me the other variables. And what we've done here is show the variables that seem to be the most important variables to show here. We also have the key factors when we do some either our domain knowledge or our own experts' intuition. So we're gonna see this. We're gonna have the domain expert be able to assign those values, so to give it some labeled data. So that is step 2. Now step 3 is, now that we've got all this intelligence and we've got all this labeled data, how can we use it? So we're going to come back in and go to the Gecko Insurance app, again, the Oracle Machine Learning Notebook, and based on this labeled historical data, we're going to build and apply focused is the word I use, but better, you know, if you don't know what you're looking for, use an unsupervised learning technique. If you know what you're looking for, use a supervised technique. Okay, don't use clustering to find what you're looking for. Use classification to find what you're looking for is the idea there. So we're going to come back into this, and I'm going to go through this a little bit, but I'll show this thing live first. I'll see if I can get this back here, because you get extra points for doing things live. So I'm going to come back here. Here's unsupervised learning, and if this is not timed out on me yet. So now I'm going to go back in here, and I'm going to sort these guys based on supervised learning. Okay, so I've made a couple of small edits on here. I'm going to load the notebook up, and again, it's the similar data set. The first data set was claims 0, where we lacked any kind of labeled data. Here we're going and we're using claims, which now has the labeled data. So the notebook is almost the same. I took the first notebook and just kind of duplicated that, but then used code from some of the other supervised learning notebooks, and I'll show you what I did here. So I now display the data, but there now is this other field here, fraud found, yes or no. So that looks like my labeled data. So I can build a classification model here now. So I do some of the same data understanding, visualize the data based on day of the week. Where is it, urban, rural, same kind of graphs I had before. But now I need to do supervised learning techniques. So one of the things I would do is create a train and a test data set. So I've just done this thing. I'm going to let this guy start from the top here again, just let this guy run while I'm kind of going through all this. Hopefully it's all going to work just fine here. And I am going to jump down here and kind of watch that play on through. So I'm going to create the train and test data sets. It only took like a second to actually run. It takes even longer for the paragraphs to sort of, wake up and say what they're doing. But I'm going to take a 60% seed, 60% sample the data, and then the holdout sample the other 40%, so I can test the data against a holdout sample to see how accurate the model is. That's what people generally do in model building. I'm also going to look at this attribute importance here first, because now I have a supervised learning kind of model. I want to see Well, what are the key factors? And it seems like base, policy, vehicle category. These are the things that are the ones that are really driving um, the model. These are the most influential variables, as we would say. So this is kind of, working its way down here. I think it's somewhere down here. I forget if I already played through or not. But now we're going to build a random forest model. Notice the code here. It's just really the same. It's this begin DBS data mining create model 2. This is maybe the more efficient way of doing this, where I can just inline specify what my target field is, my unique identifier, any parameters like how deep to grow the tree, things like that. And if you look at the documentation in the Oracle Machine Learning APIs, there's a lot of cleverness in there. There's even one I'd forgotten about, and Boreana reminded me of it the other day. When you build the models, if you go to the sample settings, I think it's ODMS_sample, you can enable stratified sampling to kick in, where you won't have to do stratified sampling. It'll just kind of wake up and do that for you. So check out the documentation. There is just a number of different settings and features in there. We also try to make this as straightforward as we can and put a GUI on this. So you've seen that on-prem. We also have the cloud version called Oracle Auto ML user interface. So all of what I'm doing here would be done basically with a click of a button. And Oracle Auto ML user interface is coming out again, I'm going to say later on this calendar year. And at the end of running Oracle Machine Auto ML click button kind of version, that would also generate the notebooks and the code. So that's kind of cool. So I've done 4 different models: random forest, generalized linear model, support vector machine, decision tree, because I don't know which is the best model. I'm going to evaluate the random forest GLM. I'm going to join them all together and put up a cumulative, like a comparative lift cumulative gains chart here. And they're actually all kind of similar. So at this point, I think what I said was I'm just going to pick one. I can't remember which. I picked the GLM. Why? Because a lot of people are comfortable with GLMs. So now I'm going to display the suspicious claims in descending order. There they all are. And it's a male and certain, the policy number, so I can sift through all these things here. I can also display these claims by age of the policy holder. I can do some other, I don't know what happened here. I'm going to skip over that. I can do some, show the top 5 most suspicious claims. Just for repeatability, I'm going to just create another table here. I'm going to leave it in the database. So there's my final table, my suspicious claims table. And I am now going to go back to PowerPoint and see where we are. So I've split the data. I've done my attribute importance. Now there's a number of different models we could have used. I mean, we did use them all, but we wanted to pick one. So we looked at them all, we compared them all, and we picked out one that we thought was a good one. And in this case, they're all pretty similar. We used the GLM model. We created our suspicious claims table. And what did we do with it? We left it inside the database, right? So now let's look at our suspicious claims data using Oracle Application Express. So this is something that I've been working on. Well, I guess I showed this already. I was working on those Do-Hoon Kim. And so here's a slightly better version of it. We're kind of playing around with this, saying, well, let's put a probability threshold in here, and what's the prediction? And here's the prediction details. Remember what I showed you before? Here it's laid out a little bit better. But as I update this, I can click on this and it will update the graph and show everything. So it's a very nice way of working with this. Previously, I showed you this for the purpose of labeling the data. Here, I'm also using it just to kind of visualize it and see it. So a lot of nice graphs. Oracle Application Express comes for free. So it is really quite an impressive tool. And if you had a map, you could lay them all out on a map. You can do a lot of cool things. But now we want to tell the whole story here. And I think what we're going to do is go over to Oracle Analytics Cloud. Now, I'm watching the clock kind of go by here. I think we're still good on time. And I'm going to see if I can find over here that window. Okay, so this is now Oracle Applications Cloud, and this Oracle Analytics Cloud. And this guy hopefully is not timing out on me here yet. I guess not yet, but I have Oracle Analytics Cloud. This is what Jasmine was saying. It does cost in certain cases. There's, I don't know, free versions on-prem, I think is what the deal is. But it's a wonderful tool. And so like the Application Express that I was using before, I get to make tables and different things, but I can also go up here and start putting in filters, it's a little bit more active, more interactive. I can say the vehicle price. I can say just the cars that are those ones, and everything will update based on that. So it probably happened kind of quickly there. I can check the marital status and just say just the married people, and I could say the prediction, just the in this case this is actually one would be a suspicious one in this case. So there's the most suspicious guys, and I might want to go off and check those guys out, right? So I can go up here and clear all the filters and so on. So very a nice interactive visualization. I can do many other different things. I'll get to my favorite one in a second here, but similarly, I can go through here and say witnesses present, no. I really want to focus on those guys where the prediction or the probability of that prediction or the police reports are filed. Is a very nice way to sift through the data. Past number of claims previously, maybe with my intuition, my hunch, I have that, and I have the prediction probability. So the ones that are the most suspicious ones are where there's no previous claims or 2 to 4 claims, I guess. If it's 1 claim, it's a little bit less likely. More than 4, for some reason, that's less likely, I guess, collectively. More exploratory graphs, and you can go to town. You know, if you've seen anything that Philippe Lyons and others have done, they can do probably I know they can do way better than I can here. But here's my favorite part of this. Oracle Analytics Cloud also have these brushing techniques. Over here, if you move your mouse over here, it says brushing is on. So as I have my graphs and my tables, I might say, you know, just the guys here, this seems to be a hot spot. And now in the data, it lights up and shows me those records where that holds true. Or maybe these guys here, and that shows in the data those records where that holds true. And so I can turn brushing on or drill through for detail here. I can use as a filter, and then it would just give me just, let me see if I can get that to work. Click on that, then the whole table would just update for just those guys. So I think that's doing it right now, I hope. But it's very interactive, very handy. So now we're going to go back to our, kind of wrap this thing up. We have gone and taken all of our results, gone to Oracle Analytics Cloud. You can do things like they have this narration kind of thing where you can say, well, take a variable and summarize it. You can do a number of different graphs and different things that very handy here. But my part that I think is the coolest is the ability to take the results and visualize them over here. But there's also a new feature, which I think maybe I don't have in here. So I'm going to go back to here in 1 second and just show you that new feature, because I realized I stepped over that and did not show it. If I go back up to the main page over here, don't save, I just want to go back to projects, just to kind of give you an orientation on where I am. Oracle Analytics Cloud has always had, or for some recent years has had machine learning, but more recently they've done this integration with our Oracle machine learning inside the database. So now I can come into here and I can say, well, I want to do my, forget what I named it. Okay, here's my support vector machine fraud, and I just created just now. Here are the input columns, here are the output columns. I can register that model. I think I already have it registered, but I guess I'll register it again if maybe I have a different one, I don't know. And now I can come back into here. You'll see it as a registered model down here. These are all the models that I've built inside the autonomous database. They are fair game for me to use, and I can come up here and set up data flow, and I can set this up as, I think I already have this done, so I'm not going to do it completely right now, but I set up a data flow, which is add data, and there's a whole step here. I'm going to skip over this because I didn't rehearse this, and I'm wondering why that still hasn't loaded up here. I guess I should just call up a previous data flow here rather than trying to do one data flows right here. So let's see. Here's suspicious claims. Let's see what I already have done here. It's timed out on me or something here, so I gotta update that. But it'll have a flow of, you know, data set, model, score data set. There it is right there. Data set, apply the model. The model I've applied is the one I created, save the data set, and all of that is happening now from inside. There's my prediction probability for the model I created, the insurance claims model. So it really is, you know, pretty cool, I think. Now, if Abby were here, she'd be able to also demo this part live, but we also have the graph, the relationships, like in the check fraud one, or in the automobile insurance claims one, you'd have like, I wrote a check to you, you wrote a check to me, and I then sent it over to Roger or Groot, or and it went around the place. All of these connections are all also tracked inside the database. It's using the graph database concepts inside the database. So I can go through here and also sort of drill through these and find those hotspots. We're using graph. I could use spatial. All those different data types are fair game for me. And so, Abby, I'm sorry I'm not able to show your stuff as well as I know you would, but this is pretty impressive once she goes through this whole thing. Here's the different relationships. Here's the transaction amount. And you might want to take a probability on what the likelihood of this transaction being fraudulent is, and then go with an expected value and sift through your data in that way. So you really can do cool things. So at the end, Abby and I are now, these superheroes. We're Batman and Robin, and we've solved all your crime problems in this fun little scenario here. And I think there are a couple of more slides here. If you need more information, it's in the deck, but we have tutorials, we have links to get the software, there's other hands-on labs, there's blog series, lots of good stuff. And that's how to reach either Abby, who we're sorry she wasn't able to make it here, or myself. And Roger, are there any questions after all of that?
They're not. It's quiet and silent. You'll notice I've got little groups whispering in my ear as well now. So
I have to see that.
But no, there are no questions. It was interesting to me that Deadpool morphed into Batman, because I can imagine Batman dealing with data.
Who knew?
Anyway,
there's a question here I see from Kenny from Kansas, who is saying, how do I get started? So I'm going to show that real quickly here. Kenny, thank you for that question. I'm going to share a portion of my screen. What I'm going to recommend that you do, Kenny, is go over here to, where is it? I'm going to go over here, and I'm just going to open up another window somehow. This guy here is kind of out of the way. I'm going to suggest you Google Oracle machine learning. There's a lot of different places to go to, but this is probably the quickest way. Oracle machine learning getting started. Okay, so this, if you just do that, you'll get to this little YouTube video that I think we have out on the internet and on the blog sites and various kind of places, but it's the quickest way, I think, to kind of show you how to get going.
Let's get started with Oracle.
You go up here, and I'm going to turn the volume off. You go up here, you sign into the cloud. And this, you can do this, guys, for free, right? You sign into the cloud, you log in. This is my free version of my cloud account. And then it asks you for your password here. Don't anybody use my same password. And then you log into here. I'll speed this up a little bit. You get into the cloud, and now you launch an autonomous database over here. I guess I disposed of a couple of those things, COVID concerns. You launch the autonomous database, and then you start something up, and you get into here where you now have a database. You go into the service console. And here's the tricky part, and that's why I wanted to show this. You need to go into the administration panel first, and you need to create and manage OML users. So you have to actually kind of create these users. So go in there first as admin, create a user. I've created the Charlie user in my free Charlie account or whatever here. So I am both admin and the Charlie user here. And then as a Charlie user, I can log in over here and get back into my notebooks, and I'm now logged in as Charlie. Okay, that's what you need to be, a sort of a mere mortal. I go in here, there's no notebooks, so I'm going to go down to here and go to the examples. I'm going to see all the examples. I'm going to open one up, and I am going to, sometimes it may take a little while for it to open up, and there's my notebook, and I'm just going to go to the top and I'm going to download it. And then I go back in and I import it into my own space, and then I can edit it and do whatever I want. That's the quickest way to get going. And so then you have your own notebook, and off you go. So I just wanted to show that real quickly. Any other questions from anyone?
No, it's just someone saying, awesome stuff, Mahesh Devarakanda.